Voila. There we go. Recording begins. All right, guys. So I'm going to go ahead and today we're going to do something called an expanded frequency distribution. So now if you're lost with this here, I've posted a video on it and you should be okay. Now we're just going to do the continuation of this. All right. According to our book. So I can erase these things. You already know that. You know this. So let's assume that you know how to create all this. You've put your numbers in order. Okay. You found your range. You've obtained your class width. You've created your classes and you counted your frequencies. Let's just assume you know that. And let me go ahead and give myself a little bit more space here. So this is the sum of F equals to 25, which is correct. It's how many numbers we have up here. So now we're going to go ahead and talk about class midpoint. Now it's not always useful to have classes. Maybe you want to do something with a class, like make graphs and stuff, and this is not the best way to represent it. It's one of the ways, but not the best way. So we have something called midpoints or class midpoints. We just write midpoints. And now it's kind of like, this is just one number we're going to come up with. So I'm going to leave it as big like that, but it really doesn't take up that much space. The class midpoint is one number that we pick that's in the middle of that class interval. This interval here, if we pick the middle number, we can say that that middle number represents that class. So how do we do class midpoint? The way we do class midpoints is we take the lower class limit, add the upper class limit, and divide it by 2. 7 divided by 2 is 3.5. So this here, the class midpoint will be 3.5. And now you repeat it for this one. You take 8 plus 15 divided by 2. That's 23 divided by 2. That's 11.5. And you keep on doing that for all of them. Now don't overthink this. This is just a class midpoint. It's just another representation for classes. And you'll see once we get to graphing why we need it or why they ask us to get it. So it makes sense. You know, if you have a range of numbers here, and they're all the same width, by the way. All these have a class width of 8 because we made it that way. Then you can see why maybe picking the middle one as the representative of that class could be useful. Any questions or concerns? Notice.
Mister,
Yes, go ahead.
can't you use any other number? Why just 2, like in the denominator? Why only 2? Can't you use like 5 or 6 or I don't know?
Oh no. Okay, so this is midpoint. So all right. So if you have 2 numbers, the way you figure out the middle number is by adding the 2 numbers and dividing by 2. And since this is class midpoint, that's why we have to use 2. Because we're forced to because of the formula for midpoint. That's how we figure out something is in the middle. Do you understand that?
Yeah, thank you.
Yeah, you can't, it's just, this is the formula. The formula for midpoint, I guess I'll write it this way, is x1 plus x2 divided by 2, where this is the first number, second. You can interchange the second and first, it doesn't matter. Okay? Commutative, right? So just, that's the formula. Can somebody tell me what the next one would be, the next midpoint? This one here?
19.5.
19.5, perfect. Now, could somebody do me a favor and take 3.5 and add 8 to it?
11.5.
And could you add 8 to that?
No way,
19.5.
mister.
Uh-huh. And what about 8 more to 19.5?
27.5.
Now, I want you to take your time and go ahead and do the following calculation. Take 24 plus 31 and divide it by 2.
Yeah, it is. It's 27.5.
This will also come out to 27.5. And I guarantee you the next one, if you add 8 to it, you'll also get the correct number as if you would have done the full math. Okay? Now, just a word of caution. You know, you could do it either way. But if you're going to do it either way, just get it right. With a calculator, a lot of people do this. They go, oh, 8 plus 15, divide by 2, and they get the wrong answer. Okay? What you do, so I did it the wrong way, and it gave me 15.5 for this one. It's supposed to be 8 plus 15, get that, and divide it by 2. Some of you might say, oh, well, what if I put a parentheses? Then you're fine. You put a parentheses on the numerator, and you can all do it in one shot. I don't do it that way, because that just feels like I'm adding extra, you know, pressing extra buttons maybe. Okay? Questions or concerns? My wife is bothering me about my daughter's Zoom. Okay, questions or concerns on class midpoints?
No, sir.
We're good? Nothing else to it. That's what it is. Okay? Okay, so let me go ahead and do something here on the computer quickly. Okay. So the next concept we're going to go, I think that was a pretty easy one. Don't you agree?
Yes.
Yes.
Yeah.
I think it was super easy. All right, so after midpoint, we're going to talk about something referred to as relative frequency. So here we have relative frequency. Again, we don't need, you know, normally I'll just abbreviate it. Relative freak, like, you know, like freak with a Q, not like frequency. And sometimes when you look at your frequency, sometimes it's kind of hard to compare a class to another one. Sometimes you might want to represent it as a decimal or as a percent. In this case, we want to represent as a decimal, but a decimal can be represented as a percent very easily by moving the decimal place over twice to the right, multiplying by 100, however you want to refer to it. So what is relative frequency? Well, it's a proportion where we take frequency and divide it by the total. So you take 8 and divide it by 25. I know I wrote that kind of small, but I don't have much space. 8 divided by 25, that gives me 0.32. So this class here takes up about a third of all the data. And you can see it when you see that, as long as you understand decimals, you can see that this takes up about a third. It's another way of rewriting frequency. The next one's also going to be 8 over 25. So the other one takes up a third. So between these two, you have about 60, actually you have 64% of the data is just being taken up by these two classes right there. And then you do the next one. You take 3 divided by 25. 3 divided by 25. You get 0.12. And you know the next two are also going to be 0.12 because they're also 3 divided by 25. And this is called relative frequency. It's when you take your frequency and divide it by the total. So you just get a different representation of the same thing. You're representing it over base the total. That's all you're doing. Now, another interesting thing that happens here is if I add up all these relative frequencies, guess what number I get?
1.
Yep, 1.00. That's very important to check when you're doing relative frequencies. Not only that, you have to also remember that sometimes you don't get nice numbers like these. I mean, I'm not saying these are nice numbers, but I'm just saying that they're, when I put it in my calculator, I didn't get like 0.32657, whatever. It was a nice number. Mama, I'm recording. Bye, Mama. So that's the main thing here, that sometimes you get rounded numbers and you're forced to round. And what happens is when you add up at the end, you don't exactly get 1. You get something close to 1. You might get here instead 0.99, and that's okay. Sometimes you might get 0.999. Sometimes you might get 1.01 or 1.001. That's okay. Now, it's not okay. It's not okay to get 1.2. It's not okay to get 0.98. Figure out where you round. Your rounding is lackluster. Sometimes some of you get confused on how to round. Now, whether you round 2 or 3 decimal places, some people might say round 2, some people might say 3. You get more accuracy as you round more, but it depends on your measurements too. So we might have a discussion on significant figures to do it properly. Okay. Any questions on relative frequency?
Can the sum of the frequency over the total, can it be 1.1?
No, 1.1 is too much of a jump. It's too much of a jump. 1.1 would be too much. No.
Okay.
Now, guys, you saw I wrote n here. This here is n. The sum of f is n. We have how many numbers? We have 25 numbers. So in statistics, we use n to do the count of all of the size of our sample, whatever it might be. Okay. Questions or concerns?
No, sir.
Yes. We're good?
Yes,
okay.
sir.
Don't overthink this. It's just we're doing an expanded frequency distribution. Now, the next thing I want to go ahead and do is called cumulative frequency. Cumulative frequency. And so a cumulative frequency is like a running total of your frequency. For instance, by the time I get to 7, how many numbers would I have counted?
8.
8. Very simple. But by the time I get to 15, how many numbers would I have counted?
16.
Uh-huh. By the time I get to 23, how many numbers would I have counted?
19.
16 plus 3 is 19. 19 plus 3.
22.
And 22 plus 3.
25.
And that's called cumulative frequency. Does anybody, yeah, go ahead.
For the homework, this is all, you're just going to give us all of this?
I'm going to give you
chart?
that.
Uh-huh.
And then you go and do everything.
Okay, perfect.
Okay. And of course, after you turn it in, I would grade it. Now, guys, I realize that the nature of this is that you can actually just copy people. But if you're gonna copy people, just try and understand what's happening. Okay, it's okay to turn in your assignment, and I can't tell if you copied somebody or not. Okay, but the idea is because of the nature of what we're doing in this virtual stuff, it's kind of nice that we can maintain some integrity. Okay, so just do it. If you have questions, bother me about it. I'll be honest with you. I think by 3:30, if I'm actually teaching, which it seems like what I'm doing, I'm kind of tired, and then I have the business to attend, and I'll try to answer your questions, but it's good if you ask me questions during class. That way I can make sure I get it to you, because it's kind of hard, like at 9 o'clock or 8, answering an email from you when I'm like, have to work with my good daughters, or I just want to chill, or I have to do a proposal, or maybe I want to play a video game, So Let's try it. You know, it's harder, but whatever. We'll figure it out.
Wait,
All right.
Mister,
Yeah.
I didn't understand. So okay, so how did you get to 8, 16?
All right. So,
No, how did you go from 16 to
all right. So I'll erase it. Here we go. So by the time we get to 7, we have how much total?
8?
This is a running total, okay? 8 plus 8,
16,
16 plus 3,
19.
19 plus 3,
22.
and 22 plus 3.
25.
That's it. That's how you do it.
All right, got it. Thank you, Mister.
No problem. Okay. So now we're going to do the last one. It's called class boundaries. Class boundary. Now, this is the last thing we're doing on this expanded frequency distribution or table, however you want to refer to it. So, if you notice, when we created these classes, there is a gap between 7 and 8. And there's a gap between 15 and 16. And there's a gap between 23 and 24. And there's a gap between 31 and 32. For the purposes of this book, they want to destroy that gap so we can eventually create a histogram. And a histogram, the bars have to touch. But if we use these classes, the bars won't touch. So for example, here we have, I'm gonna make a table. Let me see if I have a better marker. So here we have a table. We have a frequency on the vertical axis. We always have that. Frequency normally, for the most part, is gonna be on the vertical axis. And so here, let's go ahead and do from 0 to 7, and we say it's 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have a bar that goes up to 8. So there it is. It went up to 8. But now when we do 8 to 15, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 has a little gap. And so that now we don't have a histogram. We have a bar graph. So there's a sense of discontinuity between those two. In this class, bar graphs will have separation. The type of data we want here for that is qualitative data. But when we have quantitative data, we don't want those gaps. Okay? We want to use a histogram. All right? We don't want that discontinuity because we're trying to show the behavior. Well, we're trying to show the behavior the other way as well. But for quantitative data, like in this case, we can't have that gap. And this gap is being artificially created by our classes here. Let me see, I got some chats here. Let me see, because I know some people's mics are not working. Just tell everyone to turn the camera on, bet. Okay. So, whatever. Okay. So, how do we get rid of that gap? Well, there's a few ways. But the easiest way is you look at this and you're like, okay, what if this guy grew this way and that guy grew that way? You know, one goes like this and the other goes that, and they meet in the middle. Would that work?
Yes.
Yes. So what's the middle? How much is the middle between 7 and 8? How much would you have to grow and the other one get smaller by?
5.
0.5.
0.5, correct. So what I do is I say, okay, 7 grows to 7.5. But 8 gets smaller to 7.5. You see that? Is there a gap between these two now?
No.
No. So now I repeat that procedure. On this side, I increase it by 0.5. And on this side, I decrease it by 0.5. And I do that over and over again. So 15 goes to 15.5. 16 goes down to 15.5. right? 23 goes to 23.5, but 24 goes down to 23.5. 31 goes to 31.5, but 32 goes down to 31.5. And then the question becomes, do we make 39 to 39.5?
No.
Yes, we do.
Oh,
Because we have to conserve the width. And do we make 0 to negative 0.5?
yes.
Yes, we have to. And now, could somebody tell me what 15.5 minus 7.5 is?
8.
Mm-hmm. Could somebody tell me what 7.5 minus negative 0.5 is?
8.
8.
It is 8. Everywhere you do your class width here, it's conserved. That's why we had to make sure that this one, we also went negative, left 0.5, subtracted 0.5, and this one we added 0.5. We had to keep doing it for everything consistently. And now you've created your class boundaries. And you've closed the gaps. And you've kept your class widths. You conserved your class widths. I know this feels artificial, and it is. Everything we've done so far is not like, it's just a way of doing it. It's not concrete mathematically. It's just, hey, let's do it this way. Hey, let's do the range and divide it by how many classes we want. And round it up and then create it this way. There's several ways of doing this, but this is the way we're doing it for now. And then I'll discuss other ways that we can do it. Okay, so since we started graphing, I might as well try to end the day graphing. Or do you guys have any questions right now before I proceed?
No.
We're good?
Yes, sir.
Any questions on class boundaries? I know some people freak out about class boundaries.
So we put like the 0 to a negative 0.5 and the 39 to 39.5 to maintain the width, right?
We have to, in order to be consistent, because then you have one of the bars to be, the first bar and the last bar are going to be thinner than the other ones.
Okay,
Okay?
thank you.
Okay. All right, so we're going to do some graphs. Okay? And then by the time this is done, we basically would have done all of section 2.1. I'm not looking forward to it, honestly, because I think it's a big jump. How do you guys, do you want to go ahead and try and do graphs now?
Yeah.
Okay, let's do it. So again, I'm gonna draw a vertical axis. It's always frequency. I'm gonna draw horizontal axis. Now, the first graph I'm gonna do is called a frequency histogram. Now, this data here is going to be quantitative. I can't remember what this problem was about. I think it was about reading newspaper times. So then maybe this here should be newspaper times. And so the first thing is we're going to graph the frequencies. So each frequency you can graph it with you can either have midpoints here or class boundaries. If you were to use midpoints, the first midpoint is 3.5. The next one is 11.5. And I kind of try to make these as nice as I can. If I pick this width, then I'm going to try and consistently do it over here. 19.5, 27.5, and 35.5. And so that would be on my horizontal axis. Those are the newspaper times. And this represents this class. And this represents that class. And so now I go ahead and do my vertical axis. 1, 2, 3, 4, 5, 6, 7. Oh, look where 8 ended up being. So now here's the middle. So since it's midpoint, then like I go to the middle here and then I kind of like do the same thing over here, and the midpoint's in the middle of the bar, and it goes up there. Oh, that's really bad. Let me fix it. I mean, it's bad, but, and there we have it. And now I do 11.5 also has 8. So now this side's taken care of. In the middle of here, go up, meet this guy, we're good. The next one is 3. So I come here, oops. The next one's another 3. This one's wider, but whatever, I'll fix it. That's better. And the last one is also 3. Notice where the midpoint is, in the middle of my bars. Histograms, the bars have to touch. If they're not touching, I have to mark it wrong because I'm telling you right now, they have to touch, and I made them touch.
Mister, I have a problem.
Go ahead.
I can't draw straight lines.
Well, then you're gonna need a ruler. I have trouble doing it too. Try your best.
Okay, I'll try my very hardest.
Just try and try and use the side of a book or a ruler, you know, or anything that's straight, relatively straight, side of your folder or something like that.
I tried and it came out kind of curvy, but it's still cute.
All right, man. Any other questions, guys? Is this okay?
Pretty easy.
I think it's easy. Now, we can also do this with class boundaries. So what I'm going to do now is I'm going to erase all my midpoints, right? I'm going to erase newspaper times, but this is newspaper time. Let me erase this so I can have some space. I could have done this instead with class boundaries, right? I could have done the same thing, but all I do now is this first one here on this here would be negative 0.5. Then that one, 7.5. And then 15.5. And then 23.5. See, the class boundaries, the boundary. Then you have 31.5. And then you have 39.5. And I could have also done this frequency histogram using class boundaries. You could have used midpoints or class boundaries. Now on a test or quiz, I will tell you what I want you to use because it's easier for me to grade that way. But for a frequency histogram, you can use either class boundaries or midpoints. Are we good?
Give me 2 seconds, mister. I'm putting the x-axis.
That's cool. Okay.
What's 55 divided by 2?
50 what?
55 divided by 2.
27.5.
Thank you.
Okay. So I want to go ahead because this is simple.
Wait, can you give me a second? What are the numbers on the
Here?
X? Yeah, 'cause
These
it's
are,
blurry and I'm having trouble.
yeah, they're the class boundaries. So
I know they are, but like the last 3.
okay, let me make them prettier. All right, so they're exactly what you have over here. So the first one is negative 0.5 to 7.5. So this one's 7.5. Then it goes from 7.5, which you don't write again, to 15.5. Then the next one is going to be 23.5. Then this one's 31.5. And the last one's 39.5. And it makes
I know what I did. I put it in the middle, like the other one, and didn't put it to each line. So I was one short.
Okay, so make sure for class boundaries, they're not in the middle anymore. They're on the edges of the bar. Remember, the bars have to touch. Remember, the whole reason no problem. The whole reason we created class boundaries is to close that gap. The midpoint, it kind of was like a shortcut to it. Like, hey, here, put it in the middle. We just made them come together. So I want to talk to you about the next graph. In the next graph, I'm going to temporarily erase this line here. And I'm going to also erase the bars. I'm going to try, I'll rewrite frequency, it doesn't matter. So the next, I'll leave that axis because we can use it again. So the next one is called a relative frequency histogram. So this here will now be relative frequency. Okay? So if we look at our relative frequencies, it's a completely different set of units, I guess you could say, a different scale. And so this is about a third. So you have to make a decision. It goes up to 0.3, as high as 0.3. So if you use 0.10, it'd be 0.10, 0.20, 0.30, 0.40. I'm going to go ahead and use 0.05. So here's my first line, 0.05. This is 0.10. This is 0.15. This is 0.20. This is 0.25. This is 0.30. This is 0.35. And the last one up here, which you're not going to see, is 0.40. 0.40. I didn't even have to go that high. I could have stopped at 0.35. So we're going to use class boundaries because for the relative frequency histogram, we can use midpoints or class boundaries again. And so for the first one, it'd be from negative 0.5 to 7.5, it'd be 0.32. So I just go ahead and make a bar and like I'm gonna eyeball it like around here, 0.32. And the next one's also 0.32. Here we go. But the next three are 0.12, all of them. So just a little bit over here, like 0.12 is like around here, whatever, a little bit higher. I don't know. Here we go. Here we go. And here we go. And I've just created a relative frequency histogram using class boundaries. That's it. The key here is, do you know how to do the scale? Now, a lot of students, what they do is they make a line or two and they put 0.12 and 0.32 and they don't follow a scale. Remember, you have to pick a scale. You can't just go ahead and put here 0.12 and then put 0.32. That would be completely wrong because you don't have a scale. You need to keep scale. And the reason we have to have a scale is because if we don't, we can create misleading representations of the data. And that's done all the time in marketing. In marketing, a lot of times the material is created, and if you take a look at it, you're like, look what they're doing. You know, they're yes. Yes? Alanis, go ahead.
Oh no, miss, it was an accident.
Okay. So a lot of times marketing is done that way to where it'll mislead people and people look at it and they interpret the data and it's in a way that's favorable for the marketeer because that's what he's trying to do. He's trying to sell you products, but he's being deceptive and they use various ways of doing this. And mostly it's playing around with the scale. That's the best way they do it. That's the easiest way for them. And if you're not informed, then the marketing stuff makes you buy stuff that you maybe shouldn't have. Maybe it's not a big deal. So just the more intelligent you are with the numbers, the better it is. Obviously, we run the risk of being too cynical, but I guess that's the risk we run for trying to be smarter or more informed. Sometimes we're wrong though. You could have done this same thing, but instead of using class boundaries, guess what you could have used? Nobody gets? Yeah, you could have just done the same thing, but now this is 3.5 in the middle. You see, not at the edges. This would have been 11.5. This would have been 19.5. This would have been 27.5. And this would have been 35.5. Okay. So now we have to go ahead and do another type of graph. This is a completely different graph. It's no longer a histogram. It's actually a line graph. So I'm going to go ahead and erase this here and put frequency and polygon. The next one's called frequency polygon. And now I could leave the relative, but I'm not going to teach it with relative. It could be done with relative, doesn't matter. I'm going to do it with frequency. Go ahead and erase all these bars because they're useless. But now I'm going to tell you that for this graph, you can only use midpoints. Only midpoints. That's the first thing. Our scale, since we're doing frequency, our frequency, which is on the y-axis, is going to be 1, 2, the highest one is 8, 4, 5, 6, 7, 8. I kind of messed up there the scale, but whatever. You get the idea. And so for 3.5, what would be the frequency? It'd be what? For 3.5, what is the frequency?
8.
Yes. And then we'll go up here today to 8 and we put a dot. For 11.5, it will also be 8. For 19.5, it would be what?
3.
3. And then we have the other ones being 3 too. I know this is getting kind of sloppy down here, but I'm going to try to make it less sloppy so it's not confusing. So 3, 3, and 3. And then I go ahead and connect the dots. And I would almost be done. I would almost be done. But is that a polygon I've just made, or is it just a line? You guys remember what a polygon is?
It's a shape.
It's a shape. It's an enclosed shape. It's not enclosed, is it?
No.
No, it's not. So I'm going to make it close. So I'm going to make a line. And let me go ahead and move that 35.5 a little bit. I'm going to make a line over here. What do you think this line has to be? What number would that be? What is my
I
class?
can't really see the numbers, so like I can't guesstimate what the next thing would be.
Well, it doesn't matter. Let's just say this line is the same width as this line. How much is the width between here and here?
8.
8. So how much would be the width here and here?
8.
So what's 35.5 plus 8?
43.5.
And this next one is 43.5. It's a make-believe midpoint I've created that's the same class width, but then I can do this to it and go down. And guess what I have to do on the other side? I have to make a line here. I'm going to go down here. But what would this midpoint here be? It would be 3.5 minus what?
8.
8. What's 3.5 minus 8?
Negative 5.5.
Negative 5.5. By creating those additional midpoints, I hope I spelled this right, midpoints, by adding and subtracting 8. That's the key to doing a frequency polygon. Does that look too hard?
It's a bit complicated, I'm not gonna lie.
Well,
No, it's
what was,
pretty-
okay, so let's break it down. We can only use midpoints. So for 3.5, putting that dot at 8 is not a big deal, right?
No. No, like I got it. It's just like it's just complicated.
It's something that you have to practice. So,
Exactly.
okay. Questions or concerns from anybody else? Okay. So now we have one more graph. And it's called, this is called, it's another line graph, by the way. It's called a cumulative frequency graph. So guess what we're plotting? We're plotting These guys. Okay, I'm gonna go ahead and start from scratch here. So the first thing I do is what's my vertical axis gonna be? It's gonna be what? Cumulative frequency.
The frequency.
In this case, we call it cumulative frequency. Cumulative frequency. Some of you might just put CF. Here it is. So it goes up to 25. So is it okay I do it in fives? 5, 10, 15, 20, 25. Pick that scale. I mean, you can pick whatever scale you want. This is convenient for me. I'm going to go 5, 10, 15, 20, 25. Now, for this, you can only use class boundaries. So down here in the horizontal axis, you have to use class boundaries. You can't use midpoints. Now, I'm going to ask you a set of questions since we're using class boundaries, and you answer them. And that's what will tell us where to put the dot. What's the first class boundary? What's the number I'm going to put here? What's the first number of the first class boundary?
Negative 0.5.
Negative 0.5, yes, 0.5. Now, listen to my question and then answer it. By the time I've counted to negative 0.5, what would be my cumulative frequency? How many numbers would I have counted by negative 0.5?
1.
Is there any such number here that's negative 0.5?
No.
No.
So how many numbers would I have counted?
So no numbers.
Nothing. But by the time I get to 7.5, how many numbers would I have gotten by 7.5? How many numbers?
8.
8. So that means by the time I get to 7.5, I would be here. By the time I get to 15.5, how many numbers would I have counted?
16.
Uh-huh. I know 15.5 doesn't exist, but if 15.5 is here, how many numbers would I have counted? It would have been 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that would have been 16. By the time I would have gotten to 23.5, what would be my cumulative frequency? 19. It's around here. Some people like putting the numbers here to help the audience out. By the time I get to 31.5, I would be at 22. I know the spread is not the best. And by the time, I get to 39.5. Not too spread out, but whatever. How much? 25. You're plotting, boom, 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 boom. You don't have to come back down for that one because it's not a polygon. It's a cumulative frequency graph. And those are the 4 graphs we're going to be focusing on in this class. So let me stop the recording. And here it is.